So this is the second problem that we will solve, and this problem is, you got this problem as in one of the versions in quiz number 7. So it's an important problem, so I wanted to re-explain it to you. So to know how to draw the shear and bending moment diagram in an easy way and a quick way, not without using the section method. So the section method, it's more advisable to use it if the question was just find the internal shear or internal moment at a specific location, okay, because it will take time. So this is now, I will tell you now what is the quick method to draw the shear and bending moment diagram. So at A, as you can see, we have a pin. So here we have AY, AX, and at B we have BY. So the first step, we need to find our reactions. So if we do summation of forces about X is equal to 0, this is my positive sign convention, we will get that AX is equal to 0. Summation of moment about A is equal to 0. Okay, what we will get here, minus 15 times 2 minus 20. This is a concentrated moment, so no need to multiply it by distance. It's already a moment. Minus 10 times 2, which is the area or the equivalent resultant force of this distributed load, 10 times 2. And this distributed load, the equivalent resultant force is located at the middle of the distributed load. So the distance will be from here, from the equivalent resultant force till point A, will be 2 plus 1, 3, 4, and 2 divided by 2, it will be 1, so it will be here 5. Plus By multiplied by 6 is equal to 0, so in this way we can find By equals to 25 kilonewton. If we do now summation of forces about Y is equal to 0, this is my positive sign convention. Please, in the exam, you need to show your positive sign convention, otherwise you will lose grade. So here we have AY minus 15. What else? Minus 10 times 2 and plus By equals to 0. By, it's already found as 25. So in this case, AY will be equal to 10 kilonewton. Now we can come to draw directly the shear and bending moment diagram. In the exam, you need to redraw your beam with all the loading shown here. And you need to draw the vertical lines like this. Whenever we have a concentrated load, whenever we have a concentrated moment, the beginning of a distributed load, the end of the distributed load. Because why we draw these vertical lines? Because we will have change in the shear and change in the moment. So this is my shear diagram. In the exam, please don't forget to draw your horizontal reference line, because everything that is above it will be positive, everything that is below it will be negative. So we will start by, here we have AY equals to 10 kilonewton. So I need to go up. Try to change the color. So here we need to go up by 10 kilonewton. Then between this point A and the 15 kilonewton, we don't have any change in the load, so we have to continue constant. Then I have a downward 15 kilonewton concentrated load, so I need to go down by 15, and already here I have 10, so I will be going down until minus 5. Then between the 15 and the beginning of the distributed load, I don't have anything for the shear. Yes, I have concentrated moment, but concentrated moment will not affect the shear diagram. It will only affect the moment diagram. So here in this case, I have to continue straight, constant until this point. This is positive. This is here negative. Then I have a concentrated load that is downward. So I have to do minus. This is minus 5. I have to do minus 5 minus the area of my distributed load, which is 10 times 2. 10 times 2, which is 20. So here I will get minus 25. So I have to move from -5 till -25 kilonewton. In the exam, please don't forget to mention all these values, otherwise you will lose also grade. Okay, so you need to show these values, numerical values, on your shear diagram. Okay, so that's it for the shear diagram. That's it. Now for the moment diagram. The moment diagram is always the area of the shear diagram. So let's say this is my horizontal reference axis. This is my moment in kilonewton dot meter. And let's adjust the lines. Okay, so the moment diagram is just the area of my shear. So first I have this area, which is 10 times 2. 10 times 2, it will be 20. So my moment will start from 0. So this is my starting point. My second point here will be the area of this rectangle, which is 10 times 2, which is here, 2 meters. So I will get 20. So my second point will be 20. How to join these 2 points? Because here I have rectangular area, this one here should be linear, not a curve. So in the exam, please, you need to draw the lines using a ruler, just to be able to differentiate between lines and between curves. Now here I have, in this area here, before the concentrated moment is here. So before it, I have a negative rectangle. So I need to do 20 minus 5 times 1. So I will get here 20 minus 5, which is 15. So at this point, I am at 15 kilonewton dot meter. And these 2 points are joined also by a straight line because I have a rectangular area in my shear. Now, here I have 20 kilonewton dot meter concentrated moment, and this moment is clockwise. If my moment is clockwise, I need to go up. If my moment is counterclockwise, I need to go down. Okay? So in my case here, my moment is clockwise. So I need to go up by 20 kilonewton, which is the value of my concentrated moment. So here I need to do 20 plus 15. I will get 35. So my point here will be 35 kilonewton dot meter. Then I have also here a negative area. So I need to do 35 minus 5 times 1. So I will get 30. So this point here is 30. And also it's a straight line because I have a rectangular area here. Now here I have also a negative area, but this is a trapezoid. Negative means I need to do minus. So I need to do here 30 minus the area of the trapezoid. What is it equal, this area of trapezoid? It's equal 5 plus 25 divided by 2 times 2. What is that? 5 is small base plus the big base divided by 2 is always constant, multiplied by 2, which is the distance between this point and this point. If we do this, we will get 0. So my point here is closing at 0. So how to join these 2 points? It shouldn't be by a straight line because here I have a triangular or an inclined line. So this one should be a curve. One thing that we missed in the shear diagram, it's not like we missed, but always you have to close your shear and moment diagram. I mean here, my shear will start from 0 and it will end at 0. Why it will end at 0? Because here I have minus 25, and then I have By, which is an upward reaction of 25 kilonewton. So I need to go up till 25. So always remember, your shear diagram and your moment diagram will need always to start by 0 and close to 0. In this way, you can make sure that your calculation or your work is correct.